Right, hello there. In this video I'm going to have a look at condensation polymers with you. I'll have a look at polyesters and polyamides. Now, this is primarily a GCSE level video, although there's an awful lot of crossover between GCSE and A Level. Polyesters are on a lot of the GCSE courses, polyamides might not be, so please check the specification carefully. Right, I'm going to cover what esters are with you, how to form esters and how to form polyesters, then how to form amides, and finally how to form polyamides. I'll also have a look at the chemical properties of condensation polymers and how they're different to addition polymers. So we form an ester by reacting a carboxylic acid with an alcohol. So I'll draw one of each of those for you and I'll show you how we form an ester. Okay, so we've got propanoic acid and we've got ethanol. Now remember, carboxylic acids have got this functional group on their end carbon, so the C double bond O and OH, whereas an alcohol can have the OH anywhere on the carbon chain. Now, when these react to produce an ester, what happens is the OH from the carboxylic acid and the H from the OH of the alcohol will react, and that's where your water comes from. So first product, we can put H2O down here. I'll just draw the ester for you. So there's the displayed formula of our ester. If we just circle a functional group, i.e. the ester linkage, that's it there. And this ester is called ethyl propanoate. You name the alcohol bit first. Now this ester can't join to anything else. However, if we get a compound with a carboxylic acid group on either end and an alcohol with two OHs on it, we can then make our polyester. And that's what I'm going to move on to next. Now remember, this is a condensation reaction because we've got rid of H2O. So here we've got propandioic acid and ethan 1,2-diol. So let's get rid of H2O here. Remember, it's the OH from the carboxylic acid and the H from the alcohol. So we can put H2O down here. Now, of course, we can get a condensation reaction occurring at either end here. So the other OH from the dicarboxylic acid and the H from the second OH group on the diol can, of course, allow other dicarboxylic acids and diols to join on. What I'm going to do now is I'm going to draw the repeat unit of this polyester. So there we go. Hopefully you can see what I've done. I've removed the OH on the left from the dicarboxylic acid and the hydrogen on the right from the diol. Now, if you wanted to turn this into an equation, you could put an N in front of your dicarboxylic acid, an N in front of your diol, and then we can put this in square brackets, put an N outside the square bracket, and then we get 2 N moles of H2O. So the differences between condensation polymers and addition polymers. So remember, addition polymers, we've only got one monomer, that would be an alkene. We don't get anything else produced, and they are inert. That means they're unreactive, and the reason for that is because addition polymers are saturated and non-polar. That means they're a real pain to get rid of, they're non-biodegradable, they don't break down in soil, and a lot of them will give off toxic fumes when they're burnt. Whereas condensation polymers, we get two different monomers. So for a polyester, it's a dicarboxylic acid and a diol. You get a small molecule produced, which is usually water. Now these are polar, so these can be broken down in hydrolysis reactions, so you can react them with acids and with alkalis. And condensation polymers, for that reason, tend to be biodegradable, so they will be broken down by the microorganisms in soil. Right, I'll move on to amides now, which is going to lead into polyamides. Now, this is on a lot of A-level specifications, but only some GCSE specifications, so please check before you listen to all of this. Now, we form an amide by reacting a carboxylic acid with an amine. So bear with me, I'll draw a carboxylic acid and an amine for you, and I'll show you how that's formed and how an amide linkage is formed. So there we go. Now, of course, the OH from the carboxylic acid and one of the hydrogens from the nitrogen on the amine react to produce our H2O. And then I can draw our amide and show you an amide linkage. If you're looking at this from a sort of biological perspective, an amide linkage, of course, is a peptide linkage. So there we go. There's the amide produced by the condensation reaction of ethanoic acid and 1-aminoethane. Now, our amide linkage is here. So there we go. All right. Now, to produce a polyamide, we need a dicarboxylic acid and a diamine. So I'll show you how that works in the next slide. Okay, so to make a polyamide, we've got a dicarboxylic acid and a diamine. So therefore, water will be produced with the OH from the dicarboxylic acid and the H from the amine. And then that'll go with another hydrogen as well. So let me draw the repeating unit. So what I've done, like last time, I've got rid of the two OHs from the dicarboxylic acid and the two H's from the diamine. Now, if we wanted to turn this into an equation, we could put an N in front of here, plus an N in front of there, put our repeating unit into square brackets, put an N down here, and then we get 2N moles of H2O. Okay, so that's condensation polymers, polyesters and polyamides, hopefully made simple. Thanks for watching.